All right, welcome back, computer science students. In this video, we're going to go through our loop program, the very first loop we run in assembly. So far we've talked about the basics of writing an assembly program and compiling it, how to add values, and how to debug. And so now we are going to dive into how do we loop. And we're going to see how our loop works through the debug system. So to start with, again, we use nano. So nanoloop.s is what we'll call it. We're always going to start our programs off with a comment, the name of the file, what it does. Let's see, we will run a simple loop to see how they work in assembly. And the author. And so we'll always start the same way, dot syntax, assuming I can spell correctly, unified, dot global underscore start, and then we'll start with our start label and dive into our program. So we're going to start with creating our counter, and we're going to return our counter at the end of our program. So we could treat this as if it's the variable I, and we'll assign it the value 1 to start with. So we're going to move 1 into R0. That's similar to creating a variable called I and assigning the value 1 to it. So the next thing we're going to do is, this is actually going to be the first, I guess the second label that we'll create. If we're going to create a loop, we need a label to loop back to, and we don't want to start our loop by setting I equal to 1 every time. We want to set I equal to 1 once and then dive into our loop. And so we're going to create a loop label down below. All right. So in our loop, the first thing we're going to do is add 1 to the value stored in register 0. We're going to do this by doing add R0, R0, 1. This is effectively writing I++, which is a normal part of our looping structure here. We will then compare, this is our first compare command, our I variable, or R0, to the number 50. Let's do 50 loops, I guess. And so this basically says compare R0, in this case I, to 50. And this will set flags in our comparison register, essentially showing, is R0 less than 50? Is it equal to 50? Greater than 50? Less than equal? Greater than equal? All these flags are set when we do this comparison. And so now we're going to run to our first branch command, which allows us to loop. So we're going to branch when the comparison that we just performed had a result where the first value was less than or equal to LE, the second value. So this says branch less than or equal. That means if the last comparison run had a result that was less than equal, which means that R0 was less than or equal to 50, then we will branch to the label provided. So what this means is if I is less than or equal to 50, go to loop. Right, so we're going to go to our loop label if I is less than or equal to 50. Assuming we're calling R0 I here. All right, so then I guess we can say that if we don't jump to 50, right, anytime that I is less than 50, we're going to jump back up to loop until eventually our I gets to 51. Once I is 51, we are no longer, this less than or equal is no longer going to be true. 51 is not less than or equal to 50. And so we're not going to jump through the loop, which means that it's time to exit our program. And so this is like below our loop. And so we're just going to move R7 1. So we're going to store the value 1 in R7, and then we're going to perform our program ending interrupt. Now, if you remember, hopefully this has dawned on you, the value we return from this is going to be the value stored in R0. So what value is that going to be? Is it going to be 1? Is it going to be 50? Is it going to be 51? Or is it going to be something else? Well, let's find out and make sure we understand how this works. So again, Control X or Escape X, type a Y to save it as loop.s. We have our loop.s program created now. So let's go through our assembly process. First, we assemble our assembly file into an object file. So we'll call this loop.o. We'll make that from loop.s. Then we will link our object file into an executable. So our executable we'll call loop, and we'll build it from our object file, loop.o. And now if we take a quick look at our file layout here, we have loop.s, loop.o, and loop, the executable, highlighted in green. So we could do a quick non-debug run and hopefully it works, but I think you'll find that often it doesn't, and so you'll want to jump straight into debugging. But in our case it does. So //loop runs. Did it work or not? We can try our echo command again. And we got the number 51. So if earlier when I asked the question, what do we return, 1, 50, or 51? If you said 51, good job. We'll talk about why that is as we run through our loop, and we'll see it in our debugger here. So let's quickly debug. Let's create a breakpoint at start. And then let's run to that breakpoint. And then let's do layout regs, or layout registers. Although I think regs probably works too. I haven't actually tested it. Yeah, regs works too. So now we're going to be able to walk through our code step by step and run instructions step by step and see how this looping process works. And by the way, if we look really closely at our code, we have a start label, and then we have loop label, and then you see loop plus 4, plus 8, plus 12, plus 16. Each instruction is 4 bytes. So this is saying that we're going to run one instruction, and then loop plus 4 is the next instruction after the loop label, and then our BLE, and our move, and then our exit. So these are all of our commands. And again, the white line is the line that's about to be executed. So let's do NI for next instruction. We start by storing 1 in register 0. This is our I variable, our counter variable. And then we'll hit enter. That means that we are now in our loop and we've added 1 to I. So I equals 2. We compare I to the value 50. Now before I do this really quickly, I wanted to highlight our CPSR register. Keep an eye on it. When we run this comparison, that register changes. You don't need to know all the details of these hex values. It shows you hex values like this would be an 8, which is 1000, right? And then all the way down here there's a 0001 because we have a 1 in hex. And so this register is 8, 16, 24, 32 is 32 bytes, or sorry, 32 bits because of the number of hex values. And so this is a 32-bit register that stores the result of comparisons as like this complicated series of flags. We don't need to know what those flags are, but you should see this update anytime you run a comparison. And then the appropriate flags are set to show that 2 is less than or equal to 50. So the less than or equal to flag would be on here. Just interesting little background for you. All right, so because 2 is less than or equal to 50, our code jumps straight from this BLE command back up to our loop. So what if we run it? I'm going to hold down enter a few times and we'll just watch our 0 update. So we're running instructions over and over and over and over and over again. Our loop is continuing to run and 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 run. And I goes to 50. Compare I to 50. I is still less than or equal to 50, right? Because it's actually equal to. So we are still going to jump one more time and update I to 51, right? So now when we run our comparison between I and 50, I is now no longer less than or equal to 50. And so this loop should not run again, right? We don't branch back up to the start of our loop. Instead, we move down to our exit condition. And so one important thing to note, the value 51 is returned because this is the first time where we are able to exit our loop, because our loop runs whenever I is less than or equal to 50. So I does actually make it to 51. And so we'll exit our loop and quit our program, and we are done. So we'll quit the debugging process and not create a core file of GDB. All right, cool. So we got to see our loop program run, and we got to cycle through it. Please let me know if you have any questions, and I will see you guys later.